So now we're going to cover the rational zero theorem. And this theorem is pretty useful at times when we are going to get into factoring polynomials. It's pretty useful in certain cases. So to start the video off, I just wrote out the theorem. So it basically states if ax minus b is a factor of a polynomial f of x, or with the factor theorem, f of b over a is equal to 0, all that means is that this b value here is a factor of the constant term in f of x, and the a value is a factor of the leading coefficient in the polynomial f of x. So for example, if we are asked to list out potential factors of this polynomial 6x cubed minus 5x squared minus 21x minus 10, what would they be? Well, the factors are going to be linear, so they're going to be in the form ax minus b, and we know that the a value is a factor of the leading coefficient. So what's the leading coefficient in this polynomial? Well, it's this 6 right here. So we know a is going to be a factor of 6. And what are potential factors of 6? What whole numbers? Well, it could be either plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6. All right, these are the whole numbers that are factors of the leading coefficient 6. Now the b value of any potential factors is going to be a factor of the constant in our polynomial, and our constant is 10, if you see here. It's negative 10. It doesn't matter whether it's positive or negative. The factors always have to be plus or minus. So what are some factors of 10, or what are all the factors of 10? Well, you could have plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. So now taking all of these individual factors of a and b and then combining them into the ax minus b form, we get a list of all of these potential factors for our polynomial. So notice how all of these factors are linear, and the numbers that are attached to the x, so this 1, 2, 3, 6, are factors of our leading coefficient. So those are our a values, and then our constants in these linear factors are factors of the constant in the dividend. They are our b values. So it's a pretty big list, and since this polynomial is a degree of 3, we know that there are at maximum 3 factors. In fact, the factors are, if we were to factor this polynomial, it would be x plus 1, 2x minus 5, and then 3x plus 2. Alright, so out of this whole list here, x plus 1 would come from this batch, 2x minus 5 would come from this batch, and then 3x plus 2 would come from this batch. So overall, not too useful of a theorem, if I can be honest. I mean, out of these 3 factors of our polynomial, we had to choose them from this huge list of potential factors, and that's pretty tough and time-consuming to do. This theorem is pretty useful, though, once we get into factoring polynomials, and when we're dealing with these factors that have an a value other than 1. So when the a value is 1, like here, this 1x plus 1, those kinds of factors are easier to find, but when the a value isn't 1, those factors are tougher to find, and that's when this theorem can be pretty useful. In fact, we're going to go over the process of factoring polynomials in the next video, so make sure you watch that because it's a very important component of this course.